Spectrophotometry is used to detect the concentration of chemicals in solution. A spectrophotometer measures how much light of a particular wavelength is absorbed by a compound in solution. The higher the chemical concentration, the higher the absorbance. Most spectrophotometers used in biology labs measure absorption of visible and near-visible light of the electromagnetic spectrum. Review the information in your textbook about the electromagnetic spectrum. We'll only work with the visible and near-visible wavelengths. A spectrophotometer houses a light source that produces a broad range of wavelengths and uses one or more adjustable filters to select the wavelength passing through the sample. To begin using the spectrophotometer, locate the power switch. For this model, the percent transmittance knob powers up the system. Turn it on 5 to 10 minutes before you begin working. Your spectrophotometer may have a primary filter to select a general range of wavelengths. Here, the primary filter allows wavelengths between 340 nanometers and 599 nanometers, or between 600 and 950 nanometer light to pass through the sample. A more sensitive secondary wavelength filter narrows the light to a specific wavelength, such as 660 nanometers. For this spectrophotometer, pressing the Mode button sets the spectrophotometer to display transmittance data or absorbance data. These data characterize your sample. The sample holder receives the test tube or cuvette containing the solution. Inside the sample holder, the filtered light passes through the sample. The spectrophotometer is calibrated to zero transmittance by adjusting the zero transmittance knob. The spectrophotometer is also calibrated to zero absorbance by adjusting the percent absorbance knob. Now let's demonstrate how to measure the absorbance of 490 nanometer light and 660 nanometer light by a 65 milligram per milliliter or 0.5 molar solution of cobalt chloride. Turn on the spectrophotometer to warm up and stabilize. For this video, dilutions of cobalt chloride have been prepared and labeled. Calibration blank is also prepared and is a test tube identical to the sample tube, but the calibration blank contains only the solvent and not the compound of interest. Here the solvent is water, so the calibration blank is a tube of water. To begin, adjust the primary filter range to include 490 nanometer light. Adjust the wavelength filter to 490 nanometer light. Press the Mode button to select transmittance and be sure the sample holder is closed. The empty closed holder positions a barrier that blocks all light and simulates 0% transmittance. Adjust the transmittance knob to 0% transmittance. Next, clean the outside of the calibration blank. Handle the tube only by the top centimeter or two. Now put the calibration blank into the sample holder and press the Mode button to select for absorbance and adjust the absorbance knob to read 0. Remove the blank and insert the clean sample tube. Allow the meter display to stabilize, then read and record the absorbance value. Absorbance values range from 0 to infinity, but most values are between 0 and 2. The absorbance value for cobalt chloride solution at 490 nanometers is 1.68. Now let's test for absorbance of 660 nanometer light. Remember that we're using a new wavelength, so we need to recalibrate with the blank to 0 transmittance and absorbance. Adjust the primary filter to the range that includes 660 nanometer light. Adjust the wavelength filter to 660 nanometer. Press the Mode button to select transmittance. Be sure the sample holder is closed and adjust the transmittance knob to 0% transmittance. Put the blank in the sample holder. Press the Mode button to select absorbance and adjust the absorbance knob to 0 absorbance. Remove the blank and insert the sample tube of 0.5 molar cobalt chloride. Allow the meter display to stabilize, then read and record the absorbance value. The absorbance value for this 0.5 molar solution at 660 nanometers is 0.316. Cobalt chloride absorbs a lower percentage of 660 nanometer light than it absorbs of 490 nanometer light. Remember to recalibrate the spectrophotometer with every change in wavelength and treat the spectrophotometer with care. When finished, turn off the spectrophotometer and clean your work area.